All right. Good morning, everyone. If you guys want to, in the back there, take a seat. There's a couple of seats down here if you want to grab front row seats. So I wanted to just kick things off this morning. Welcome, and thank you for making the time here. I know it's a big time commitment to carve out your day to come to this event. We've actually been doing these at-scale events for, I think the first one we did was June of 2013 in this room, so it's about a year and a half ago that we kicked off these events. And we started this with really kind of this idea of how do we bring together a set of people that really care about the types of problems that we see and we work on, right? And these typically involve big scale, or they involve stuff that's really hard. And we wanted to bring together people who care about these types of problems. And we've done this in a way that we've kind of focused in on a couple of topics over the years, right? The first one was related to sort of analytics and data. Then we moved on to doing some stuff in mobile. And then we did a session in security. And there's been some other, we did one on sustainability, sort of, energy and what we've done in the data center and whatnot. So we've had a bunch of these topics that we've dug in really deep on, and we brought together this community. And really, I think we're pretty excited about today because it's the first time we've done the actual networking at scale event. We've got a great and awesome lineup of speakers and presentations today, so hopefully you guys will find this stuff really educational, really valuable. Ask questions, meet people. This is a really, really, I think, awesome set of people that we brought together. Everybody here likes building stuff, fixing stuff, right? So we're all engineers and want to get into the gory details of these solutions and these problems. One interesting stat is actually we ran some quick math on this, and the companies that are represented here in this room represent about half of the traffic in North America in the internet. So I thought that was pretty awesome. The other half we couldn't actually invite because it's porn. Joking, maybe. So I just wanted to close with a couple of thoughts here, which is, one is that we have a really good set of presentations today to talk about some really cool stuff, and each company that's presenting is going to talk about some problems they're working on and some new solutions and stuff that have been being worked on. And then also, there's going to be lots of opportunity for you guys to mingle and get to know each other and sort of talk to each other and follow up and hopefully meet some new people here today. Ask questions. Really, the key part of this is, stay awake and have fun. With that, I'm going to turn it over to Omar, and he's going to walk you through the day.
Thanks so much, Jay. So welcome, everybody. As Jay said, this is our first networking at scale. Really super excited to see so many familiar faces, but then hopefully this is a good opportunity for you to meet some new people, too. The whole point of this is to be open and to share, and we're really excited by the lineup of folks. A number of us were talking just a few months ago, like, whom would we bring to create this whole agenda for this day? And it's frankly amazing that we've got all these people, speakers, willing to share and talk openly about this, from web scale, large web scale operators, talking at the hardware layer, at the low-level data center layer. We even have folks from the financial area where it's not about milliseconds, it's not about microseconds, it's about nanoseconds, right? And then we started to look across the whole stack, right? Okay, let's move up a little bit. What about the applications that are trying to run on top of these networks? And then we'll actually even get into content distribution and then into the mobile space. So hopefully you should find something in the whole agenda that really speaks to you, and hopefully you'll find a lot to learn from all the different talks, right? Logistically, we've got a couple of talks first, then we'll have a break, then another set of talks, then lunch, and then we'll pack it in the afternoon, right? One thing also we wanted to point out, we're hosting this here at Facebook, so we are all about sort of social media, right? So we totally encourage you to be posting and sharing within the groups here. The one thing also we wanted to point out that everyone who's here is going to be part of a closed sort of a Facebook group where you can just ask questions. What did I hear about? I have a question for this speaker. I wanted to know a little bit more about this, and so you're all part of that group right now. And please use that to ask questions and to continue the conversation even after the event is over. Right. So great. So with that, we'll go to the first speaker. So Anis and I, we crossed paths actually over a couple of years, kind of in the whole SDN and software-defined space, OpenStack. We were crossing paths there, and we both had sort of a similar transition. He was at IBM working on their product portfolio, transitioned over the last year to Google, to kind of on the operator side, right? And we were comparing notes. Same thing for me. I switched into the operator side here in the Facebook networking team. And a lot of the learning that we've had over the past couple of years is around just how hard it is to operate these things. Right? So we talk about kind of what's the new software-defined protocols and new control mechanisms we can do. But a lot of what we do is just making this operational. How do we monitor? How do we configure? How do we deploy this at scale and as quickly as we can, right? And so that is what Anis is going to be speaking to you about today. How do we bring some of these software-defined networking notions into the operational space of management and configuration? So, with that, Anis Shaikh.
Thanks, Omar, and thanks again for inviting me. Thanks, Najam. My name is Anis Shaikh. I'm with the network architecture team at Google. I wanted to share a little bit with folks here today about what we're doing in maybe the least sexy part of networking management, but one of the most important. In particular, we're trying to bring these notions of SDN and programmability automation to the management plane. You'll have to forgive my voice. I'm getting over a cold. Hopefully it will last through the talk. So I wanted to cover three main things today. One is to motivate why we're spending so much time looking at this, some of the challenges in the management plane. Then I'll talk about some ideas that we have in terms of how we might bring programmability to the management plane. We've done a good job of this as an industry around the control plane, and there's been so much advancement on the data plane side. The management plane, unfortunately, is the stepchild that never seems to get enough attention. And then I'll talk about an exciting new initiative that we've started with a number of other network operators called OpenConfig. It's really an attempt to sort of bring a community development approach to how we build out models for the management plane. So I'll talk about that at the end. So as you may know, at Google we have a pretty big network. We have edge pops on our user-facing backbone that span 33 countries, so over 70 of these. We've also got a back-end backbone that connects all of our internet-scale data centers together. You may have heard of it as B4. We've talked a lot about B4 in various venues. And then in terms of traffic volume, if you have seen some of the statistics about YouTube, they're a bit staggering. Hundreds of millions of hours of video viewed every day over our network, and over 300 hours of video that gets uploaded per minute on the network. So there's a lot of stuff going on in the network. It's large, complex, and there's a bunch of challenges in actually managing and running the network. So I'll talk a little bit about on the configuration side. We have lots and lots of network devices. More upwards of 20 plus roles of network devices, which means each of these roles has a specific set of policies, configurations, the way they interact with the rest of the network. And so we have to keep managing these as we introduce new parts of the architecture. We create new roles in the network. We may deprecate other roles. So these keep changing. There's like 4 million lines of configuration files. I spent the last few months at Google looking through this stuff. This is kind of not really a great metric. It's kind of like using lines of code for software, but it gives you some sense of, and in fact, the number is a bit high because we've tried to simplify the configurations. But you can see that there's a lot of volume of configuration to manage. We have a highly heterogeneous network. We have more than a half dozen vendors in our network, some of them with multiple platforms. So there's a lot of work in actually managing this heterogeneity on the software side in our tooling. We did a study recently where we looked over the course of a year in terms of how many config changes that we're pushing in the network. It turns out that in some months we actually push more than 30,000 configuration changes, just in terms of turning up new links, maybe bringing down links, draining links, moving traffic. All of these config changes result in a very dynamic, pretty complex environment. And then we have a few software engineers at Google, and they like to write tools, and we have lots of them. And we have many generations of them also, because in this kind of environment, you're always iterating. It's very sort of organic in the way that these tools get built sometimes. And so we have lots of tools and multiple generations of them. So even just managing the software stack that we have is a challenge. So as you can see, there's a lot of opportunity here for significant savings if we can get our heads around some of these issues. So in particular, these configuration changes often result in outages because of various kinds of mistakes or unexpected side effects. Having some way to sort of reason about configuration changes, simplify the way we do configuration, has significant potential to reduce the impact of those outages. As I mentioned, there's a lot of room for simplification of the management stack, sort of bringing everything under a single framework as opposed to having a different set of tooling and reasoning about each and every network environment. And then, of course, by building this stack as a distributed system, we have the opportunity to scale it up as we need to for different parts of the network. Unfortunately, the tools that we have at our disposal, as many of you know, are way behind where they need to be. So we still have to deal with lots of proprietary CLIs. We manage tons and tons of scripts. If you have a big distributed team managing the network, they tend to write scripts as they need them, and then it becomes a problem to sort of rationalize and turn them into a cohesive set of tools. We're still stuck in this world of what we're able to do on devices, which is typically very imperative incremental configuration. You put the device in a certain mode, you run a bunch of config commands, then you finally commit it. So you basically have to spell out every step of the configuration that you want to do. What you really want is something much more declarative about, get me to this state, as opposed to here are all the things that you need to do to get there. We don't have any real abstractions in the management space, right? So we think in terms of kind of device configurations, low-level policies, and that's the level at which we're manipulating things. There's a lot of I think many shops still do a lot of configuration scraping, so that means that the authoritative state of what the network is doing really lives in devices, which is the wrong way to think about this. But at the same time, this is really the main set of tools that we have. And of course, SNMP is still our monitoring tool, de facto monitoring tool. There's nothing really simple about it. I don't think it's anyone's favorite tool, but it's what we all use. So I'll say a little bit more about monitoring. One of the things that are a concern of any large network operator is running the network efficiently. And running the network efficiently means having really good visibility into what's happening in the network. We run really tight control loops. We're doing fairly sophisticated traffic management on the backbone. It requires us to have a great deal of visibility that is not stale. It has to be real time. But unfortunately, in the monitoring space, as we said, SNMP is still our de facto mechanism, but it's poorly suited for this job. There's a lot of issues with it. I don't think I need to spell them out for everyone here, but legacy implementations is one. Some of the SNMP implementations on devices haven't changed since the device was kind of introduced, or that software was introduced. So that's a problem because it results in fairly poor performance and scaling. It limits what you can actually monitor. SNMP is also poorly suited for extending. So as you find that you need to collect new types of data, it's very difficult to extend SNMP to now add this new data type that you want to control. There's really no limited, I should say, capability to extend the data model. It's highly proprietary, right? You have to use lots of vendor-specific tooling to get vendor-specific counters and other data sources. Okay, so what would a more programmable management plane look like? So there's a few things that we've been thinking about in this space. As I mentioned, or as the title of the talk sort of implies, we tried to think about this in terms of software-defined networking. We've made a lot of progress on the control plane side, as I mentioned. We've talked about a lot of it publicly in terms of how we run the B4 network. And we've also done, of course, a lot of stuff with our vendors on the data plane side. But the management plane is still a place where we haven't really figured out yet how we want to apply SDN principles. So some thoughts about that. So one of the principles of SDN is the separation, right, of control and data plane. If we think about this in terms of configuration, one way to think about it might be that this is the ability to separate where the authoritative knowledge about what the state of the network is from devices. So scraping config off of network devices doesn't really make for authoritative state, right? You want the state of the network to be managed in a central controller-like abstraction where the network devices are made to go into the state that the controller believes, as opposed to the other way around, where the controller has to query the devices to figure out, oh, what state are you actually in right now? This notion of centralized control is also very important in SDN. We have the same kind of things that apply in the management plane, right? So we need this network-wide visibility over the configuration and some coordination across all of the devices to build a full picture of what's happening in the network. As I said, we have a lack of network abstractions. Abstractions and APIs are also a key part of SDN, right? There's a lot of attention being paid to what does the northbound API for SDN look like, or what should it look like. There's a similar issue in the management side, right? So we want to actually extract knowledge from living in code. So you have tools and code that actually encapsulates a lot of knowledge about that particular environment, as opposed to having a model that represents the state of the network that then you can manipulate with code. So that's sort of raising the level of abstraction of how we manage the network. And as far as APIs, one example of an API that we're looking for is in the visibility space and monitoring, where we really want to move toward a more pub/sub API for monitoring than what we're stuck with today. I'll talk a little bit more about that. And then finally, one of the other things that's happened in the SDN space in the industry is the introduction of new standard protocols that at least have some promise of interoperability. I'm not sure if we've gotten quite there yet, but with things like OpenFlow, with open source projects, Open Daylight, OpenStack, with the OCP work, we have a lot of work happening around creating sort of standard platforms that can be used across different environments, protocols that work across different vendors. In the management space, we really don't have anything like that. So what we're looking for is some standard set of configuration models, of monitoring data models that we can use to enable us to manage this heterogeneous environment in a much more unified and cohesive way. I have to keep lubricating because otherwise, pardon me. So we said a lot about network models. So what are the models that are important? We actually focus on kind of three main models for the network that we think are important to enable this sort of SDN-style control or management. One is a topology, right? So the topology model basically is intended to describe the entire structure of the network. And we do need a common modeling language for this. So we've developed one internally that we are using, and I've talked in other forums about the possibility of us introducing that in the industry. But regardless of what modeling language you use, the state of the network in terms of topology is crucial. A lot of configuration can be derived as sort of intent on the topology, right? When you're draining a link, for example, you're changing the topology or changing an attribute on the topology. When you're moving traffic around, you may, again, change a policy on a particular link. All of these can be thought of to some extent, not all changes, but many changes in terms of changes to the topology. So it becomes really important to be able to represent the topology in a model that can be then consumed by code and automation to figure out how to generate the configuration to effect that topology change. So we're looking at models for the topology. As I said, we've developed some of these internally that we're using. We can encode the data in a lot of different ways for the topology. We're using our favorite one, protobufs. The next model that's important is the configuration data. So this model describes the structure of the configuration of the network, and in particular network devices, as well as their content. And the model can also be used to validate the configuration data once you generate it. I'll show you some examples of that. We've adopted in OpenConfig and within Google, we're looking closely at using Yang. It's an industry standard developed in the IETF. It has its problems or drawbacks, but we're trying to use it because it's something that's actually being supported and pursued in the industry by a lot of vendors that we work with. And Yang has the nice property that you can, in fact, think of it separately from netconf and XML. You can encode data that's based on a Yang schema in lots of different formats. We're looking at protobufs, at JSON, at other more efficient or self-describing formats. And then finally, you may not think of monitoring data. I mean, SNMP has sort of a data model, but it's not a model in the sense of being very extensible. But we need also a model to describe the telemetry data that we're collecting, right? So this model describes the structure and the attributes of the data that we want, maybe the frequency of the data, the precision of the data, the structure of it, how to access it in a well-defined schema. And we're also looking at potentially using Yang for this purpose. Yang has the ability to model operational state data. Again, it has its own set of issues that we're trying to work through, but we are exploring to use this. It actually would be really nice if we could put the configuration and the operational state data in the same schema. This is the main reason why we're looking at Yang to express both, because it becomes easy then to correlate intended configuration state with the monitoring state that you want to learn about. And then here again, you have the same set of options as far as how you encode the data. So what would a configuration system like this look like? So again, we're trying to make the analogy here to SDN. This is sort of a picture of the canonical SDN stack that we all have sort of come to adopt. You have the network application at the top that consumes a set of northbound APIs, which are an important layer in and of itself. We have a network operating system which actually converts those API calls into a bunch of state changes in the network. And then we have a set of southbound protocols that actually talk to devices over different protocols or other mechanisms. So what is sort of the analogy in the configuration space? So we think of the application as sort of the configuration intent, right? So operators interact with an intent that they express on the network to change its state from one to another. Often, also looking, as I said, with topology, policies, design rules, all of these things come into the configuration intent. And the northbound API can be encoded in these models, right? So we have these models that define what the API to the configuration system is. There's an API to the topology to learn about the topology. There's also an API that I haven't shown here for the telemetry. So this you can think of as the API or the northbound API of the system. The analogy to the network OS layer could be thought of as actually the whole machinery that takes these changes that have been stated at the intent level and converts them into actual configuration changes, right? So you have an authoritative store of the current configuration. It's versioned, of course, so as you generate new configurations, you can track them and track their provenance. And you have standard models by which this configuration is generated. And then finally, you have the equivalent of sort of the southbound protocols, which is basically your configuration pusher, which can take lots of different forms. NetConf is a standard in IETF. RESTConf is similar to NetConf, but using HTTP as a transport. And then there's other options, JSON RPC, et cetera, et cetera. And you can see that the configuration flow here should just be downward, ideally, right? You're not pulling configuration from devices to learn what their state is. If you are observing the network and you suspect that the network state has gotten out of sync with what you expected or what you want, you basically overwrite the configuration with a new one. You don't sort of pull the configuration, analyze it, and then try to figure out what happened. You just declare what you want the configuration state to be. That's the sort of idea that we're after here. Let's talk also a little bit about the telemetry side. As we said, what we need to have is the ability to monitor the state of the network in real time in this time series fashion. So we really want to have streams of data which can come in at high volume from all these different types of network devices into collectors that we can use to then analyze the data, look for state changes. You have the problem that in some cases not all the changes to the network devices are synchronous or they're not transactional. So in many cases you only know that something has happened once you're observed a change in state. And you can't do that if you're getting data at some low frequency or an incomplete set of data. So what we want to do is basically program these devices with a model, again, that describes the structure of the data that we want to get back. So it's not leveraging SNMP here. We want to have a data model that's tailored for telemetry that we can express to devices and have the devices return the data to us according to that model. So we know exactly where we need to access the model to get a specific piece of data that we care about. And then we want these things to be streamed continuously, right? So the push model is very important here for efficiency. Support for incremental updates is very important, again, for efficiency. So send us the whole data model when the device comes up, I mean, all of the data, and then send us incremental changes over time as a continuous stream of updates. Okay, so let's switch a little bit to talk about OpenConfig, which is one of the initiatives that we're looking at to actually help enable some of this. So when I talked about data models before, one of the first problems you run into is that every vendor that you may have in your network has its own model for configuration and monitoring. So you're back to the same problem of, even if you're able to move to a model-driven approach, now you have to handle and manage and maintain models from every different vendor. So what we really need is a vendor-neutral model for both configuration and telemetry data. And the problem is actually getting enough critical mass around this notion of vendor-neutral models. As you may know, Yang models are sort of coming out of our ears in places like the IETF and other industry forums. The problem with some of that work is that a lot of it is driven by specific vendor considerations. It's really hard to get to an operator-driven notion of what the model should be. So OpenConfig is intended to address that gap. So what it is essentially an informal collaboration that we've put together consisting exclusively of network operators. So it's a purely user-driven forum. We work closely with vendors, but we don't actually do the development with vendors. We sort of work in stages. So operators work together with a focus on defining vendor-neutral configuration models and operational state models that are based on real usage. So the way we develop these models is to actually look at our actual configuration files, look at the set of data that we use to manage the network, and write the models that way, right? As opposed to try to write the model that reflects all of the configuration knobs that a particular device supports, or all of the RFCs that a particular protocol has published. So we try to focus it really on real use cases as opposed to all the features that you may have in a given device. As I said, we've adopted Yang as the data modeling language. Again, this is primarily because it's what the industry seems to be supporting. A lot of the vendors who we are partnering with on this are already developing Yang models that reflect their own configuration models or telemetry models. So it makes sense to use that. One of the things we're most pleased about is the set of participants in the effort so far. It's not a huge list, but we think it's an important and telling one. So in addition to ourselves, we have folks like British Telecom and AT&T and Verizon, who I have put there, that's sort of one class of network operators. We have cable operators like Comcast and Cox. We have web scale operators, Microsoft, Facebook, all involved. So these guys all operate different kinds of networks, different sizes of networks, networks that have different services that they're providing. So it gives us a pretty broad base of use cases on which to base the model. So the idea is that we want a vendor-neutral model that serves all of these use cases, as opposed to just one that is focused on, what Google's needs are, or what AT&T's needs are, or what BT's needs are. So we have a model that has use cases that are reflected by all of these operators. Our primary output in OpenConfig is the code for the models themselves. And we publish the code as open source via GitHub repo. So we tried to style it like an open source project, since the main artifacts that we're producing are in fact code. So the way that we do this is that basically operators work together to define the models, write and author the models, and then periodically we push them out to a public repo where the wider community, including vendors, including standards folks, can all look at them, give us feedback on them, tell us why they don't make sense, et cetera, et cetera. So we're trying to engage the community, but at the same time make sure that the models reflect real operational usage as opposed to other perspectives. And then we get a lot of questions about, well, why aren't you doing this in the IETF? We are interacting quite a bit with the IETF here, so we do publish the models as drafts when it makes sense in the IETF, just so the community can sort of keep track of what we're doing. We also have interactions with the Open Daylight community. They do a lot of work on Yang there. There's a lot of expertise there on building Yang models. So we are interacting with the outside community, but again, the focus is really on operators and their use cases. So one of the interesting things about this collaboration is that it's unique, at least in my experience in working in open source projects. And there was this blog post at Light Reading that mentioned a couple of the unique characteristics here. One is that these service providers are all different, as I mentioned, right? They all have their own sort of business models. Some of them are competitors with each other, and yet they're working together because of the urgency to get to a point where we have this level of programmability in the network. And these vendor-neutral models don't solve the whole problem, but they take us a big step towards it, towards the solution. And then also, she also pointed out that, you know, these guys, the operators that are involved here, are showing some willingness to move on their own. So we don't want to ignore what's happening in the broader community, but at the same time, we can't wait for the standards process to complete. We want to sort of do this in parallel. You know, it's interesting. We started this collaboration without a single agreement signed, a single lawyer consulted. It's just a bunch of engineers from these companies working together, getting on the phone every week, having ad hoc meetings to write the models, review them. We actually are trying to make this as low overhead and as informal as we can, and just rely on everyone's good intentions and good behavior. So even though some of the participants may be competitors, we're all facing the same challenges in operating the network. I think the goals are so aligned that it hasn't been a problem so far. I think this is one of the most interesting things about OpenConfig. One of the realistic problems that comes up with, you know, having a vendor-neutral model is there's always going to be some changes needed to the model when you actually try to use it, right? So suppose that you're an operator that has a lot of reliance on a particular vendor's capability X or Y, or you have some specific knobs that are very specific to your environment that don't make sense to put in the base model. One reason we adopted Yang is that it does allow this kind of extension, right? So if you want to build an extended model, let's say you're working with a particular vendor, vendors can actually provide modifications through, you know, Yang augmentations, Yang deviations, et cetera, where they might support, might not support some parts of the model. They might add additional nodes to the model. And then the model that you have used locally, you can also add sort of your own local modifications. So initially, I don't think that the base model will necessarily serve all use cases. The hope, though, is that we can use the base model as is, but realistically speaking, the models that each operator uses internally are likely to be the base model plus some extensions / modifications. So the base model is a starting point. We're working with vendors to actually make sure that they support all the features of the base model. Again, it doesn't mean that the base model is sort of the lowest common denominator features. The base model represents the cross-section of all of the features that all of the participating operators use, as well as consideration for what is available on most of the implementations that we have. Right? So we've actually spent a lot of time doing our due diligence on, okay, do these platforms all support this feature? If yes, okay, we can put it in the model. Because if not, it doesn't make sense. We end up with nothing more than, you know, a very small base model with tons and tons of augmentations and additions, which is not what we want. The other interesting thing about these models that are being developed is that they're kind of being developed in isolation, right? So someone builds a BGP model. I mean, we've done that. Someone builds an ACL model. Someone builds an ISIS model. Someone builds a traffic engineering MPLS model. These things are useless by themselves, right? You need to be able to put them together in a cohesive way to build an overall model for the service you're trying to stand up or the device you're trying to configure in a given role. So there has to be a sort of meta model, if you will, that describes how these things fit together and work. So one of the other things that OpenConfig is doing, because again, there wasn't anyone really in industry looking at this, although I understand that in IETF now there's some effort spinning up around this, is to define some way of how you represent the way these models connect together, right? Because at the end of the day, your model is not just BGP or not just MPLS, it's got to have everything in it that you need to stand up a particular service. So it's a critical missing piece, which we're also trying to offer a perspective from operators on. So it's often a little bit confusing how we actually would use this model. This is sort of a straw man of a pipeline of how OpenConfig models are being used and how we're talking to partner vendors about this. So you have some configuration generation logic. Let's ignore how the configuration is actually generated for the moment. This is based on your own sort of internal network operation considerations. But what you generate is actually an instance of the configuration data that can be encoded in whatever you want. but the instance is built according to this model, right? So the model describes the content and the structure, and the model can be used to validate the data that you have produced. So Yang has this feature of being able to specify at least syntactic rules about, ranges of values. If you have a string value, what kind of pattern it needs to follow, a number of different things like that that at least make it possible that the config data that you've generated has some sense to it. But that's not sufficient, right? So there's always a second step validation that you need to do from a semantic point of view. So there's an additional piece of validation that takes into account, okay, does this configuration actually match the intended topology change I wanted? Does it follow the policies that I have in place? Does it follow the design rules that we use for this particular role in the network? And then at the end of this process, you have some validated configuration that's encoded using some encoding that then you push to devices. So here, the idea is not that we own the translation of now, okay, I've generated this vendor-neutral config, and now I have this tooling that has to convert it to a Cisco config or a Juniper config or whatever config, right? This is where we're working with vendors to have native support for these models. So the idea is for the OpenConfig model to be the interface to the device to configure it and also to get data back. I haven't talked a lot about how the telemetry works here, but it's very similar in the other direction. And of course, every vendor device is going to have its own native configuration model, so there's going to be some mapping, but the idea is that the vendors can decide how exactly to implement that mapping. Now, one of the things this really helps us with is when we bring new platforms into our network, as every operator does, there's a long qualification process that has to happen. It has to be tested and integrated with our software tools, our processes, all of the rest of the machinery that happens for just that new device, whether it's hardware or software. Right? So imagine now if you had one way of configuring and one way of monitoring devices. It really simplifies the qualification process as far as integration with the tools northbound. Right? There's that interface to the device doesn't need to be tested against all your vendor-specific tooling. You have one model. So if you can test that that device faithfully translates the vendor-neutral model into the right configuration once during that process, then it really simplifies the rest of the qualification process. So I'll say a bit about progress, where we've reached so far. We've published a BGP model, a routing policy model. We're working on a traffic engineering model. These are kind of the heavy hitters that all of the operators need in their network from an infrastructure level. We have this device meta model in progress. We're working on other models that we need to build out the complete set to stand something up, including sort of service level models, L3 VPNs, for example. And then we have several discussions ongoing with a bunch of vendors who have shown, a great deal of willingness to actually support the models. They can see the benefit to their customers, meaning us, the operators, and it will really simplify how we do configuration going forward. So just to wrap up, we've done a lot of work on SDN in the control plane and enablement in the data plane. We've done relatively little. It's time for the management plane to start catching up. There's a bunch of principles here, but the core ones that we talked about are the need for actually using models to capture knowledge, not code. This idea of declarative configuration, so specifying what, not how. And then the importance of visibility and streaming telemetry as a way to more efficiently manage the network. And then OpenConfig is a focused effort by a bunch of network operators. It's a collaborative model where we're trying to build these models that we need together in a vendor-neutral way, and then work with vendors to implement them. And for any other network operators who haven't yet joined, this is kind of an open invitation. We're looking for additional use cases. We want all operators to be able to leverage the work that's happening in OpenConfig to really move more programmability into the management plane. Okay, with that, I will stop, and if there's any questions.
Hi, on this side. We are a small SDN startup writing OS for switches. I just have one comment for big operators, right? You guys can be overwhelming, and there are 50 different configurations out there, so you come out with another one. Startups can't deal with it. Cisco and Arista and all these guys will be able to support you, but the new generation of startups which are actually trying to change won't be able to do it. So the only comment I would make here is that you said you're working with Open Daylight, right? you're working with OpenFlow guys and whatever. Rally behind 2-3 efforts, basically, right? Don't create another one. That's all I would say. Startups can't deal with this.
I actually don't think there's any other effort that's like OpenConfig that's happening.
Guys, we have Open Daylight, which wants to come into switches and manage and do their plugin architecture. We have OpenFlow controllers, which are coming into switches to try and manage that. We have various other. So all I'm saying is just look at what's going on.
So I make the distinction of those projects that you mentioned with actually what we're doing from a management perspective. Neither Open Daylight nor OpenFlow are management protocols, really, right? So, in fact, Open Daylight has, I think, a gap in terms of their focus on enabling programmable management. Really, they're still focused on applications and NFV and control plane features. So I'm not arguing with the point about making it hard for startups.
Yes.
That's not the intention of this effort. But I don't think there's another effort like this that is purely user-driven in this space. There's a lot of work happening in ITF. I would have expected you to complain about that, actually.
I actually, I come from world. ITF RFCs are great, right? Get in there, whoever is there, at least there are 20 people sitting there figuring out a common RFC. RFC was a standard, basically, right? So the pseudo standard kind of, again, like I said, the world is changing very fast, right? And I understand. Guys, I'm here because I do want to support you guys, basically, right? I mean, this is very interesting stuff.
Yeah, let's talk offline about how we could enable you guys.
Just a comment.
Sure.
Hi. Is it on? I have a question. More a big picture question. I know that you talked about SDN, you talked about managing the resource in the network space, but we also know that there is the compute and storage space. And I know that, like at Google, you have this Omega paper where you manage your resource much more dynamically. So do you see those kind of coming together? Because at the end of the day, you have network resource, you have compute, you have management, you need telemetry, you need numbers. Is there some link between those initiatives?
I mean, there's certainly a link, and they should come together, right? You'd like to manage all of these and have the models unified across all the IT resources you're managing. I mean, the issue, though, is just one of practicality. I think that in the networking space, we have vendors who we work with in our network, and they are kind of adopting this style of modeling language, and it is a little bit domain-specific to networking. And to basically to expedite the process of getting to these vendor-neutral models, we're kind of going down a little bit of a network-centric approach here. But I think to your point, all of these operators also care about managing storage and compute and other resources using the same kind of mechanism. And of course, we're further ahead, much further ahead in those spaces as far as management than we are in networking.
Okay, thanks.
Yeah.
Hi. At some point, it'd be nice to see what you're doing in terms of OpenConfig with testing. About 10, 15 years ago, a few of us worked with the DOCSIS stuff, the cable modem guys. And those operators got really upset with the vendors, right? And that was the first API because they didn't want to have to deal with CLIs. So the DOCSIS guys got together, created an organization, and vendors had to pay to go test their gear. And unless they got a good seal of approval, they weren't going into operator networks.
So I think that's a great goal for the OpenConfig effort. It's still, I would say, in its infancy, though, for us to be able to think about a formal certification process. Right now, our engagements with vendors have been kind of bilateral, so you have a bunch of operators talking to vendors about, what will it take for you guys to support this model? And it's a bit of give and take, to be honest, right? I mean, we may have to modify the model to make it actually possible for them to implement it. As long as those modifications aren't specific to one vendor that, at the expense of another one that we care about, or make the model nonsensical to us as operators, we're willing to entertain those. So right now, at this stage of OpenConfig, it's still a little bit of give and take, but I absolutely agree that that's where we need to get to. Yeah.
So a couple of comments on some of the earlier comments that were made. One thing, looking at it from someone who's done a couple startups in the space, actually, to me, this seems better than what I would have to do today. If anyone has actually done this, doing your CLI and all the other classical management platforms is actually one of the big pitas about doing your product. If I have a simple data model in XML, that's much easier to work with. So actually, I think this makes it easier, not a harder gateway for a startup to work in. I'm going to slag very nicely a little bit on the IETF comment, and I can do that because I was a working group chair at one point. At one time, the IETF very much worked this way. You came in with something that was rough consensus, and you came in and said, does this make sense? Today, we've now gone to a very much design it all up front and then go see if it if it works in the IETF. So I applaud coming into the IETF with something that actually might work and have. Coming to the IETF and saying, we're a bunch of operators and we actually want to use this is actually a refreshing way of doing this rather than a bunch of vendors trying to figure out what the operators want and shove it down their throats later. As far as testing organization, that also might be paying to go test, I think is also a hurdle for a lot of startups. Informal plug fests can go a long way. I don't think you need to have a formal organization. Before you get to that point, a formal organization, you have to be members, et cetera, I think could actually slow things down rather than keep things moving along. Just some thoughts.
Thanks for the comment. Do we have time for the last one?
Let's have the last one quick question here.
Yeah, thanks. So you spoke about telemetry earlier in your presentation as well. And, as far as standardization there's been stuff in SNMP, in SFlow. OpenStack has some definitions in CLometer as well. I guess you're not really addressing that as part of OpenConfig. I mean, are you happy with the state of the art there? Is there more work that you're doing to standardize the telemetry piece?
No, I'm sorry if I wasn't clear. I mean, we're very unhappy with the state of the art. I guess that's why we think that we need the same sort of models for telemetry as we're doing for config. So one of the things that is a little bit unique in OpenConfig is that we're not ignoring the operational state modeling part of the problem. So a lot of the models that are being developed in standards and so on, they, I think, do a little bit kind of afterthought about the state model, but that's really important. So all the models that we're publishing will have sort of a detailed operational state model that we want to use for this purpose. So I think I pointed out some of the problems that we have with SNMP and so on. So I think we definitely want to move to a different state than where we are.
Well, I was speaking more about the time series part, right? I mean, that's, you can say that's part of the operational state, but sometimes it's a little bit of a different beast.
Yeah, so maybe we can talk offline about that. Sure.
Thanks.
Let's have another hand for Anis, please. Yeah, it's awesome.